This is a satellite view of the Bay of Bengal and its adjacent land borders. Securing this expanse requires joint awareness across hundreds of thousands of square miles. In the air domain, the force operates Western lineage platforms, like prospective Typhoon-class aircraft. But this sits alongside a heavy reliance on Chinese lineage hardware, including the J-10C and the bulk of the Navy's surface combatants and combat data systems. These two ecosystems are mathematically incompatible. They do not share tactical data links, they use different cryptographic keys, and their underlying data models cannot directly communicate. The commercial manufacturers of these platforms have zero financial or strategic incentive to bridge this divide for a purchasing military. Standardizing the physical hardware across the entire military is politically and economically impossible. Achieving joint effects across this mixed force requires an architectural overhaul. The most dangerous assumption a procurement board can make is that buying matching tactical radios automatically solves this interoperability problem. Two units holding the exact same modern tactical radio may have perfect technical connectivity, but unless their wider command and control systems can exchange a common operational track, they remain isolated. Interoperability exists on a strict maturity ladder. Level 1 is simple connectivity, and Level 2 is basic information exchange. Neither of those lower steps yields a Level 4 cross-service kill chain. The solution is moving from service-centric procurement toward a federated information architecture. Procurement of advanced hardware is functionally useless unless those physical systems are strictly subjugated to a shared overarching information architecture. Before the joint force attempts to establish a universal tactical data link, it must first build a resilient, IP-based strategic backbone. This diagram illustrates the required IP backbone, the connective tissue of the battlespace. Right now, native link-level fusion between Chinese and Western combat systems is impossible. To bypass this, we insert translation gateways. These act as the critical technical compromise. These gateways ingest the proprietary platform formats and normalize them into a single joint data model. This gateway-mediated architecture provides immediate joint availability of radar tracks without waiting for a flawless native data link that may never exist. We do not need to replace our mixed inventory. We only need to mandate that all edge systems speak to a translation gateway rather than trying to speak directly to each other. This brings us to the Joint Common Operational Picture, or COP. Historically, militaries attempt to build a monolithic COP, a single massive display trying to ingest every raw sensor simultaneously. That model fails. Instead, we use a federated architecture. In Layer 1, individual services gather their raw sensor detections. In Layer 2, domain fusion, the Air Force, Navy, and Army each build their own recognized domain picture first. Layer 3 is the joint fusion node. Governed by the Armed Forces Division, this central node correlates the three independent domain feeds. To prevent duplicate ghost tracks when two different radars see the same contact, there must be a single designated track custodian per domain, underpinned by an authoritative Blue Force tracking overlay. Finally, Layer 4 provides role-specific displays. A naval commander and an air defense officer see entirely different interfaces, but they pull from the exact same correlated data pool. A true common operational picture is common data yielding common operational truth, tailored to role-specific displays. Maintaining an open, high-speed information-sharing environment presents a paradox. Closing the network entirely destroys joint interoperability, but connecting everything without boundaries guarantees systemic compromise. The solution requires abandoning the concept of perimeter security. Instead, we deploy zero-trust and data-centric security. Protection moves from the network pipe down to the data object itself. We enforce this through role-based access control, authenticating every transaction. Because a mixed origin hardware inventory carries inherent supply chain risks from both directions, the network requires strict microsegmentation and sovereign cryptographic overlays. By controlling access at the data level, the overarching network can remain open for real-time sharing while remaining mathematically secure. In a peer conflict, we must assume the joint network will suffer a breach or heavy electronic warfare denial. This chart models the architecture's four connectivity states, starting here in the normal zone. When transitioning to a degraded state, a disciplined pace plan executes automatic failovers. If the environment becomes contested, the network bottleneck forces strict prioritization. In a completely denied state, local command systems are designed to fight autonomously, storing critical data until connectivity returns and resynchronization occurs. The objective of military IT is not maintaining pristine connectivity at all costs. It is ensuring the system degrades gracefully, allowing the force to remain operationally lethal even when disconnected. Technological blueprints will fail if they are not backed by centralized military authority. If a joint authority does not enforce standards at the point of acquisition, individual services will default to buying incompatible hardware silos. The most effective bureaucratic lever is mandating interoperability as a strict key performance parameter for all future acquisitions. No future system can be purchased without delivering its specific interface control document to a joint interoperability board. True joint interoperability is achieved in the procurement office, long before the hardware ever reaches the tactical edge. The equation for the modern battlespace is precise. Federated systems yield common information. That common information relies on resilient networks, which ultimately deliver joint effects. Service platforms will age out and be replaced. The information architecture is permanent. Architecture must always precede acquisition.